Welcome to this explainer. Today, we are unpacking the ultimate homeowner survival guide for navigating some truly extreme seasonal weather. We're leaning heavily on the real-world, boots-on-the-ground expertise of Grand VHC Columbus. The goal here? To completely demystify those heating and cooling systems that, let's be honest, we all rely on every single day.
Okay, let's just dive right into it. Picture this. What happens when your home's absolutely only defense against 100-degree heat or, 20-degree freezes suddenly dies at 2 in the morning? It is literally a homeowner's worst nightmare. But here is the fascinating truth. A total system failure rarely happens completely out of the blue. There's actually a real science to why these systems break down, how they get fixed, and exactly when they actually need to be replaced.
This explainer breaks down the whole shebang, from local microclimates waging war on your appliances, right down to the insider math of repairs. So we'll quickly cover the climate challenge, warning signs and breakdowns, the professional repair process, the math of replacement, sizing standards, and finally, how to maximize your HVAC lifespan. Let's kick things off with Section 1, the climate challenge, specifically looking at Central Ohio weather. It's kind of crazy when you realize how the environment itself is actively working against your home's infrastructure. We're not just talking about hot and cold air here. You've got shifting clay soil, which is super common in this region. It literally expands and contracts so much that it can actually disconnect your ductwork right underneath your house. Couple that shifting ground with the high Scioto River humidity, which just steadily corrodes your system's electrical control boards over time, and you've got a perfect recipe for major mechanical stress. And what's really wild is that your specific neighborhood's age totally dictates the unique challenges you're going to face. Take older spots like Cara Place with homes from the 1980s. They struggle a lot with aging ductwork and this discontinued, incredibly expensive R22 refrigerant. But then on the flip side, if you're living in a newer development like Ballantrae, your battles are completely different. There, you're dealing with the quirks of highly complex, high-efficiency systems that require incredibly precise maintenance just to avoid an early failure.
Moving right along to Section 2, warning signs and breakdowns.
Listen, before a unit completely dies on you, it will actually try to communicate. If your system starts making these crazy banging or squealing noises, or it's just running constantly without actually cooling your house, or maybe you see iced up evaporator coils or get a totally unexplained spike in your energy bills, pay attention. These aren't just minor quirks. A squeal could literally be a failing blower motor, and a system that just won't shut off, that might mean you've got a hidden refrigerant leak.
Which brings us to Section 3, the professional repair process.
So, you've made the call. What exactly happens when a professional technician actually shows up at your door? Well, the industry standard is a surprisingly straightforward 3-step process. First, they do a meticulous system diagnosis using digital gauges and combustion analysis to pinpoint the exact problem. No guesswork here. Second, they move into complete repairs, which usually happen in a single visit because, well, the pros drive fully stocked trucks. And third, testing and verification. They rigorously test airflow and safety controls before they even think about leaving your driveway. All right, let's dive into Section 4, the math of replacement. Because eventually, every single system reaches a breaking point where you really have to ask yourself, do you keep pouring money into repairing it, or do you just completely replace it? So how do you mathematically know when it is finally time to throw in the towel on that aging equipment? The answer comes down to a really simple, heavily relied upon magic number that the pros use all the time. That number is $5,000. Let's break down how this works. It's called the $5,000 rule. Basically, you take your system's age in years and multiply it by the estimated repair cost. If that total exceeds $5,000, replacement is officially the smarter financial move. So, say you have a 12-year-old system and you're staring down a $500 repair bill. 12 times 500 is $6,000. Boom! According to the rule, you are way better off investing your cash in a new energy-efficient unit rather than slapping a Band-Aid on the old one. And hey, if the math does tell you it's time to replace, there's a pretty nice silver lining to help soften that financial blow. The Inflation Reduction Act actually offers tax credits that cover up to 30% of qualifying energy-efficient HVAC upgrades, and that runs all the way through 2032. It honestly makes making the jump to something like a modern heat pump significantly more accessible for your wallet. That naturally leads us to Section 5, sizing and technical standards. Because if you are getting a new system, you should know that home comfort is a highly precise science. You can't just guess what size unit a house needs based purely on the floor space.
Real professionals rely on a standard called Manual J to calculate your exact equipment capacity based on the true heat load. That means factoring in things like your windows, your insulation, and even your sun exposure. Then they pair that with Manual D, which maps out the standards for proper ductwork design, making sure the air actually flows perfectly without any weird restrictions.
To put that into perspective, depending on your home's square footage, the required HVAC tonnage has to scale up pretty quickly to handle those brutal summer days and winter freezes. For instance, a 1,200 square foot home might only need a 1.5 to 2.5 ton system. But if you bump that up to a 3,000 square foot house, you jump to a 3.5 to 5.0 ton system. Sizing it right is absolutely everything. If it's oversized, it wastes a ton of energy. If it's undersized, the thing is just going to run constantly.
And finally, Section 6, maximizing your HVAC lifespan.
Because a brand new installation really shouldn't be something you have to worry about replacing for a very long time. Look at the timeline. Starting from 0 years at installation, with proper seasonal tune-ups, regular filter changes, and clean coils, your equipment should comfortably hit that minimum expected lifespan of 15 years. And honestly, it can even push 20 years maximum if you really maintain it. Furnaces do tend to outlast air conditioners, but getting anywhere near that 20-year mark means maintenance is not optional. It is strictly mandatory.
But to actually reach that impressive 20-year milestone, beyond just doing the basic maintenance, you absolutely have to follow this crucial digit 3. This is known as the 3-minute rule. It dictates that after your AC shuts off, you must wait at least 3 full minutes before restarting it. Why? To allow the incredibly high refrigerant pressure inside the system to equalize. If you're standing there impatiently clicking your thermostat up and down trying to force it to start too soon, you are making the compressor work against immense pressure, and you literally risk destroying the whole thing. Just set the temperature, step away, and let it do its thing.
Which brings us to our final thought for today. When you consider the severe stress extreme climates put on these mechanical systems, the shifting clay soils, the relentless humidity, those rapid temperature swings, is your current HVAC setup ready to survive the next extreme Ohio season? Or is it basically a ticking time bomb, just waiting to fail at the absolute worst moment? Take a good look at your system today. Listen closely for those warning signs, and whatever you do, remember that $5,000 rule. Thanks for hanging out with me on this explainer.